예, 안녕하세요. 반갑습니다. 예, 그린플럼 프로덕트 매니저인 알바 노미께서 이제 그린플럼 로드맵에 대해서 지금 소개해드리고 그 이후에 제가 이제 간략하게 서문해서 정리해서 말씀드리도록 하겠습니다.
안녕하세요. My name's Ivan Novic. Nice to see you virtually this time. I'm sorry we can't come on airplanes during the global pandemic, but I'm here to present the Greenplum 7 roadmap during the Korea Greenplum Summit. So glad to see you, and let's get started. So I'm going to begin the presentation with a short recap of Greenplum 6 and what we have accomplished in recent times. And firstly, happy birthday to Greenplum 6. Greenplum 6 was released in September 2019. It's been over 1 year since the release, and I'm happy to say that we have many very successful production customers running on Greenplum 6. It's our most stable and our highest performance version of Greenplum ever. For your reference, Greenplum 6 is based off of the Postgres 9.4 code base. So when compared to previous versions of Greenplum, we incorporated all of these 6 versions, Postgres 8.4, 9, 9.1, 9.2, 9.3, and 9.4 into Greenplum 6, and they all holistically make up the Greenplum 6 product, which makes it very, very much strong and improved. And Greenplum 6 really supports a very wide and diverse range of workloads compared to many and any large big data databases in the industry. In fact, you may be surprised to know that Greenplum 6 can support even transactions. You can do single row inserts and single row updates using indexes and see over 10,000 transactions per second running on Greenplum 6, which is very new and rare for an analytical database like Greenplum. Of course, we support traditional data warehouse queries now in Greenplum 6 with the concept called replicated tables. Our optimizer is improved as always and now supports very complex many table joins with efficient join order selection, as well as complex SQL with subqueries, common table expressions, recursive common table expressions, views, complex hierarchies of views, materialized views, and then as well in database machine learning and multimodal analytics, all in one database product that avoids data copying and data management across a many system portfolio. You can see that the multimodal analytics covers everything from traditional BI to text search and text advanced natural language processing to geospatial search, geospatial filtering, and geospatial queries, analysis of your time series data, full graph analytic capability, deep learning based on GPUs for image recognition and other hard to identify patterns, and then traditional machine learning as well. And then you can use Python, R, and Java to add additional custom functionality, all of this in an MPP single form factor, which makes up our multimodal analytics part of the product. So Greenplum 7 will in fact be based on Postgres version 12. And that will consist of Postgres versions 9.5, 9.6, 10, 11, and 12, all integrated into the Greenplum 7 product. And that brings a whole series of functionality and performance that Greenplum customers will benefit from. Let's start with the first feature, which is just-in-time compilation. Now, what is just-in-time compilation? It's the process of using compiler technology when queries are executed to change from SQL being an interpreted language to being a compiled language. So you're probably familiar from computer science that languages like C and C++ run the fastest because they're compiled into binary runtimes when you build the software. Well, in the same way, SQL is an interpreted language, but what we now have the capability to do is to take your SQL query, and when it comes into the machine, into the Greenplum system, to compile it in real time into a new binary optimized format using open source and latest compiler technology, and then to be able to execute the queries faster than they could be executed before when it was purely interpreted execution. We're going to show you a quick example. This is the TPCH data and TPCH query number 1. This query is a very basic data warehousing query from the benchmark, which does a select with a series of sums in there, as well as a series of averages and a count, and then a where clause with a time, and then group by and order by. So very traditional basic SQL, and we're going to show the benefit of just-in-time compilation. So in this particular case, this slide just kind of shows you the different options. And when we compare that, you can see that without the just-in-time compilation, it ran in 23 seconds. So we went from 23 seconds to 13 seconds just by enabling this capability to make the execution faster using compiler technology and really transparently to the end user. So imagine when you upgrade or move to Greenplum 7, these wide range of workloads are just going to be faster and use less CPU, providing you essentially access to more CPU resources than you had at your disposal in the past. Looking at the next capability in Greenplum 7 is the block range index, or BRIN index. This is a index that stores metadata at the block layer of the min and the max values of certain columns. Now, this index, what you're going to see is that Postgres and Greenplum have this ability to create different types of indexes, and we currently have B-tree indexes and we have bitmap indexes. This is a new type, and every index type has new benefits that it provides, new characteristics. Now, here's one of the first benefits you're going to see. When the index is in place, without the index, it took 97 seconds to load the data. But with the B tree, it took 307 seconds. So it was 3 times slower to load the data with the B tree index in place. However, when adding the BRIN index, you can see that the penalty for loading data is much less than the penalty for B trees. So if you're going to be having the index in place and loading data, you're going to see that this BRIN index has a much lower overhead than a B tree and allows you to continue to load data. From the footprint point of view, the space, you could see here the original data was 800 megabytes of data. The BRIN index only took 13 megabytes, so it's really small. It's a small overhead to add to the table. On the other hand, creating a B tree index was even bigger than the data. So, you know, this is an expensive index. It's maybe the fastest index to do searching on, but it's very expensive in terms of space and also, as you saw, in terms of data loading. So this is really a good compromise index that allows you to take less space and have less penalty on loading. And then when, in this particular case, you can see it was a good use case for us, and that the scan time actually was almost the same with the B tree and the BRIN index, and dramatically faster than with no index at all. So indexes are helpful, and this new BRIN index is really going to help in a lot of data warehousing and analytic workloads to speed up certain queries and to take less overhead when doing so. Upsert is a very useful feature which is new in Greenplum 7. And what this does is to help people who are operating with index tables or primary key tables and wanting to either insert a row if the key doesn't exist, or to update the row if it already exists. And this gives us flexibility in how that's done. So we give you a couple options in Greenplum 7. Option 1 is to say, hey, if there's a conflict, don't update, don't do anything. That's one option. Option 2, what we're going to give is on the conflict, do the update and set the value. So here is where you come and say on conflict, hey, update sensor value to the new sensor value, right? So it can do the update even if the key is already there. And if it's not there, it'll go ahead and insert it, right? So this allows us in one shot to insert or update. We also improved the vacuum operation in Greenplum 7. This is going to help avoid locking and disk I/O. You can see certain things here like avoiding to scan and read vacuum pages with only frozen tuples. You can see certain of the locking and using more efficient and really fine-tuning the locking during the vacuum to avoid as many conflicts as possible. And the goal really is for vacuum to be transparent. Now, when it comes to high availability, and disaster recovery, there's two major capabilities that will be part of Greenplum 7. The first thing is multiple data center or multiple site replication. So this is streaming the data from data center 1 to data center 2 through something like a Kafka interface. So this enables use cases where you need to have the availability of the Greenplum system, even in the event of a full data center failure, right? So you can expect that within minutes, that all data that's in data center 1 is updated into data center 2, and that if data center 1 goes down, we can promote this one to be the active data warehouse in data center 2, right? And so this is continually updating all of the transactions into this cluster in an atomic and consistent fashion, which allows us to have this second data center ready to take over at any time. You can also do a certain amount of read-only queries on the second data center, but the writes would have to go to the primary until this primary cluster fell over to be this one as the primary, in which case then you could do reading and writing here, and this site would become the failover. So that's what this capability enables. And then it also enables the ability to just store off those X logs or those transaction logs into a storage medium, let's say S3 or some object store or some any data storage product, and then be able to use that to regenerate a system which can restore to any point in time. So you've got your initial snapshot, then the X logs, you're storing them off to the side, and then you can bring back the system to a point in time by applying the backup and the X logs on top of it in order to recover the system to that point in time. This could be used to create secondary clusters for dev and QA, or even for having a disaster recovery solution in the cloud when the primary solution is on-prem and only instantiating it when it's needed. We will also be now kind of moving away from the core Greenplum and the Greenplum 7. Independent of Greenplum 7 release, there's a few features I wanted to mention for you that are outside components that we'll be releasing in the near future as well. So the Greenplum connector for Apache NiFi should be released as a GA by the end of 2020. And this product allows you to create, it's an open source Apache NiFi, allows you to create graphical workflows of your data and how it's ingested and how it's moved across the system. We also have some really interesting features coming in the new Greenplum Command Center in the next few months. We have an in-app notification window where you can see in the application, you can see the different alerts and the different recommendations that are coming. You can then clear those alerts as you action them. So similar to on your phone or an application or an email where you get alerts, you can read through all these alerts and act on them as they come. We're also going to be releasing an advanced history search for queries where you can go and put query text and more details about the user and the runtime and pull out specific queries based on your requirement to analyze your workload. And then you can also then export the queries from your query monitor and bring those to a spreadsheet and store those or analyze those offline as needed. So that's a new export capability. We have a feedback link here now, which opens up a feedback window. So if you have any feedback for the Greenplum team, you can go right to the command center and say, hey, I think there's a great idea. We want to improve this command center, or any suggestion. You just click the feedback and that'll come straight to us through a secure channel. So that's what's on the command center that's coming soon, and then a lot more stuff next year for the command center as well. And really, I want to summarize with the Greenplum vision for the future, this big data database and platform that allows us to store hundreds of terabytes, petabytes of data in the Greenplum system, and then to run all kinds of queries and analytics as described. So if you look at these kind of 4 key principles, the first one is performance at scale. So performance and at large scale, and scale here means ever increasing data sets, more concurrency, more users running on the system, right? So we want to have the biggest, most powerful database in the world. The second thing is the full relational database management feature set, as close to Postgres as possible, but at scale. So the feature set of relational database, the feature set of Postgres, people love it, but they want it to run at large scale. right? Even despite the fact that even a single computer can't handle that workload, it needs to scale to tens or hundreds of computers, servers running thousands of cores of CPU cores running one database. So we want as many of the full features of relational database, not only OLAP, not only transactional features, but really all the features of a database in Greenplum. And then we recognize that Greenplum is part of your data ecosystem. It's not the full solution. You need messaging, you need in-memory grids, you need object stores, you need programming languages. And we support many of these ecosystem features like Kafka and Spark and NiFi and S3, Python based on the latest Postgres. And we'll continue to monitor the ecosystem and make sure Greenplum is always interoperating with the key parts of your ecosystem. And the fourth key principle is automated operability. It needs to be easy. It needs to be easy to deploy, easy to manage. And we've got quite a lot of things coming, especially from our VMware teams within VMware that are really helping to show how can we create the cloud experience, both the private cloud and the public cloud experiences based on virtualization, based on efficient scalable storage, all of the key aspects that you can just push the buttons and Greenplum runs with as little headaches and as little interventions and problems. It needs to be automated. They call it, one of the expressions is lights out operation, meaning you can turn off the lights, you can go home and Greenplum runs without you paying attention, right? And that's where we need to be. So this is our vision for the future: performance at scale, full feature set, part of the data ecosystem, and automated operability. And I think with all of these things, Greenplum's got a tremendous future, and really looking forward to it. And I'm looking forward to visiting Korea again once we can get back on the airplane and to hang around there and to meet the customers and to see your experience and how we can help you be successful. Thank you very much and have a great rest of the session. Bye-bye and 감사합니다.
예, 다시 VMware 코리아 이상희로 돌아왔습니다. 앞에서 그린플럼 프로젝트 매니저께서 이제 좀 영어로 하다 보니까 좀 지겨울 수 있는데요. 좀 간략하게 여태까지 그린플럼 6가 어떤 내용이 있었고, 그리고 그린플럼 7에서 어떤 기능이 좋아졌는지에 대해서 좀 간략하게 설명드리도록 하겠습니다. 그린플럼 6 같은 경우는 9.4 버전을 쓰고 있고요. 그 코어 엔진에 포스트그레스 9.4를 쓰고 있고, 기존에 이제 보통 병렬 처리되는 DBMS다라고 하는 이제 정렬 데이터 위주였는데요. 그것뿐만 아니라 이제 비정형화된 데이터, 지리 정보, 오늘 얘기했던, 그리고 텍스트 검색, 오늘은 얘기 나오지 않았지만 텍스트 검색이라든지 XML이라든지 JSON, H스토어 등 이미지 분석까지 비정렬 데이터 분석까지 지원이 되고요. 그리고 오늘의 이제 좀 어떻게 보면 메인 주제였던 머신러닝 AI를 위한 이제 인 데이터베이스 고급 분석이 지원되고 있습니다. 기존에도 그린플럼 4나 5 버전에서도 지원이 됐어요. 근데 가장 큰 차이점은 최근 들어서 이제 텐서플로우라든지 케라스, 파이찬 이런 부분들이 고객이 원하는 버전을 쓸 수 있는 게 가장 큰 차이점입니다. 레티스 버전까지도 지원되고요. 기존에는 좀 올드한 버전이었다고 하면은 그린플럼 6부터는 최신 라이브러리까지 다 지원된다. 그리고 내가 원하는 버전까지 지원된다는 게 가장 큰 차이점 중에 하나입니다. 그리고 오늘 또 하나의 예제가 이제 하둡하고 이렇게 얘기가 나왔는데요. 멀티 데이터 소스 원 SQL. 이걸 어떻게 표현할까 했었는데, 하둡에 있든 S3에 있든 모든 데이터가 원격에 있다 하더라도 그린플럼에서는 다이렉트 액세스가 가능하고요. 그거를 조인할 수도 있고, 하둡에 있는 데이터, S3에 있는 데이터를 조인할 수도 있고, 그린플럼에 있는 데이터로 조인할 수 있어서 하나의 SQL로 다양한 형태의 있는 소스의 데이터를 분석할 수 있는 형태입니다. 그리고 이 기능은 생각보다 많은 고객사에서 사용하고 계시고요. 그리고 하둡이라든지 S3하고 연동할 때도 빠른 퍼포먼스를 내고 있습니다. 그리고 마지막에 이제 스팍이라든지 카프카. 오늘은 여기서 주제는 안 나왔지만 카프카 같은 경우에는 초당 한 300만 로우 정도, 300만 TPS 정도의 퍼포먼스를 내고 있습니다. 그 300만 로우의 인제스천 데이터를 밀어넣는 데까지 걸린 시간이죠. 그리고 이제 그린플럼 7에 대해서는 오늘 이제 좀 간략하게 생각보다 더 많은 기능들은 개선이 됐습니다. 근데 오늘은 시간 제약상 이 정도로 해서 이제 나왔는데요. 일단은 코어 엔진을 이제 포스트그레스 제일 레티스 버전 12 버전으로 아예 올렸습니다. 왜냐하면은 포스트그레스도 계속 진화되고 하면서 좋은 기능이 있었고 이제 그린플럼의 로드맵에서도 포스트그레의 레티스 버전을 따라가겠다라고 하는 좋은 기능들을 다 흡수하겠다는 얘기죠. 그리고 이제 그린플럼 7S는 기존의 6까지는 이제 병렬 고급 라이브 분석, 인 데이터베이스 분석이라든지 아니면은 비정형화된 데이터를 이제 처리하겠다. 이러한 계속 확장을 했다고 하면은 그린플럼 7S는 또 본연의 역할을 이제 또 제대로 하기 위해서 이제 성능적인 측면에서도 많이 개선이 됐고요. 그리고 운영적인 관점에서도 이제 개선이 됐습니다. 그 중에 이제 성능적인 관점에서는 이제 데이터 양이 더 많아지고 용량 더 많아지고 분석할 기간이 더 많아지기 때문에 그래서 이제 just in time 컴필레이션이라고 하는 어떻게 보면 기존의 쿼리를 돌렸을 때는 SQL 형태로 인터프리터 언어죠. 그거를 이제 아예 바이너리로 바꿔버리겠다고 하는 겁니다. 그래서 컴파일하는 시간은 1ms지만은 실제 쿼리가 진행될 때는 우리 장표에서 나왔던 거는 42%의 개선. 단순하게 이제 컴파일만 했을 때. 예. 그리고 두 번째는 이제 인덱스 부분인데요. 인덱스도 필요하면 이제 써야 되죠. 그리고 그린플럼에서는 이제 비트맵과 그다음 비트맵 인덱스, 비트 인덱스가 지원되는데 요번에 이제 나올 부분은 블락 렌지 인덱스입니다. 기존의 비트 인덱스 같은 경우는 이제 그 한 2기가 정도 있다고 하면 이제 13메가. 기존 대비 용량 1%. 근데 성능은 동일 성능. 그리고 성능도 개선되고요. 이걸 안 쓸 수가 없겠죠. 네. 그 다음에 이제 기능 개선된 부분들 중에는 이제 업설트 기능, 그 다음에 베큐um 기능, 그 이외에도 통계를 처리하는 부분에서도 통계도 개선이 많이 됐습니다. 그리고 이제 최근 들어서는 이제 한 2년, 3년 전에 저희 이제 프로덕트 매니저와 국내 있는 고객사 이렇게 미팅을 했는데요. 거기서 나왔던 고객 쪽의 리퀘어먼트 중에 하나가 이제 DR 구성이라든지 시점 복구라고 하는 부분들을 요청을 했습니다. 그 당시에는 바로는 안 됐지만 그걸 계속 꾸준하게 고객의 피드백을 계속 반영해서 이제 그린플럼 7이 내년 나올 건데요. 그 안에서는 이제 재복구, 그린플럼의 기간계 분석계 시스템이 요즘에는 이제 거의 기간계 시스템처럼 이제 중요해지기 때문에 이제 재복구, DR까지 구성할 수가 있고요. 그리고 시점 복구까지 구성할 수 있도록 이제 그린플럼 7에서는 이제 지원할 예정입니다. 오늘의 그린플럼 로드맵은 여기서 마치도록 하겠습니다.